In this video, we have three integrals to evaluate, and they all have something in common. The results for each of these will be an arc trig function or an inverse trigonometric function. So notice they all have a radical in the denominator. So let's review some formulas. These are setups for finding the value of an integral using the trig substitution. Here are the derivatives of the arc trig functions. You see a u, that'll be a function of x. That could be an x squared, it could be 3x. So if you don't know these, pause the video as I go through these so you can take a look. And then here's some formulas involving the integrals of inverse trig functions. So the first one tells you that if you have an integral, or if you can write an integral, sometimes it'll be in this form, sometimes you'll have to set it up in this form using a regular u substitution. So if you have an integral that can be written in this form, du over the square root of a squared minus u squared, the value of that integral will be given by arc sine, you can also call that sine inverse, of u over a. A here is a constant, plus the constant of integration. If you have one in the form du over a squared plus u squared, that will be given by 1 over a, arctangent of u over a, plus the constant of integration. Now if it takes the form du over u square root of u squared minus a squared, that will result in the arcsecant. And it's the actual answer for this form is 1 over a arcsecant of absolute u over a. Now in the ones that we're going to do for this video, they're going to involve, two of them will involve the first formula here, and then the third one will be involving the second formula here. So let's go back up. So let's look at the first one. Here we have the square root and then 1 minus, and the function part is on the right side. In other words, it's subtracted from the constant. So if you remember the forms, that's going to be the first one. So let's rewrite this one this way. E to the 2x can be written as e to the x squared. So once you know those forms, then you use your substitution. So u here, I'll let u equal to e to the x. Then du would equal to the derivative of e to the x, which of course is always e to the x, unless it has a factor there, like a 2 or 3. Then that value multiplies the exponential. So we got this then. Du equals e to the x dx. So that's your u right here. 1 minus u squared. If you remember the value for that one then was arc sine, or sine inverse, you can also call it that, of u over a. So remember the form for this one was, had an a squared here and a minus u squared. And of course, this part right here, in our case, it's going to be the du. So I could actually write it then in that form. Say, okay, the integral then is e to the x dx, that represents your du. And then it's the square root of a squared. In our case, we have a 1 there, so it's 1 squared. So for us, for this problem, a is equal to 1. Then minus u squared. In our case, u is e to the x. So now, back to this, then once you have it in this particular form here, then it's arc sine, or sine inverse of u over a. So u over, in our case, it'll be u over 1, which is just going to be u. But what is u? In our case, it's e to the x plus the constant of integration. But I checked this one just so you can take a look at those derivative formulas. The derivative of arctangent, actually, let's check it. Take the derivative of this and see if we get the original answer. Derivative of constant, of course, is 0, so all we have is this right here. And the derivative of this was the derivative, the arc sine, was derivative of the u here, z to the x, e to the x, derivative of z to the x, and then it was the square root of 1 minus u squared. So what's u? In our case, u is e to the x. If you square that, you get e to the 2x. So we use the formula for finding the integral of an inverse trig function and also for finding the derivative. This is your check for this one. And notice for the second one, it kind of looks like the first one. We have a 4 minus sine squared x. So this looks like this could be a right here. Notice your derivative of sine is cosine, so we need a substitution here again. So I'm going to let u equal to sine of x. Then du would equal to the derivative of sine, which is cosine of x, and that is dx. So notice cosine dx here. That can be represented by du. And then the denominator for this, using the same formula again for this one. A squared is 4. So I could write that 4 as 2 squared minus. And the u equal to sine, so notice here, that's a sine squared. And since u is sine of x, and this is u squared. Now, integrate here. Anything in this form would be arc sine of u over a. And in our case, the u was sine. And a, actually this is 2 squared, so a squared is 4, so 2 would be the a. So this would just be sine of x over 2 plus the constant of integration. So again, once you can get the integrand in the form du over the square root of a squared minus u squared, or u squared minus a squared, or a squared plus u squared, you can easily get the value of the integral. So for this one, it's arc sine of sine of x over 2 plus the constant of integration. And again, a quick look at the formulas. These are the ones. So far, we've used the first formula here twice. If you can get it in the form du over the square root of a squared minus u squared, then you get the answer directly from there. Arc sine, whatever you made this u, if this was just an x, then that's going to be x over whatever a is, plus the constant of integration. Now the third one has actually this form here. Integral of du over a squared plus u squared. But it's not quite there. But it's in that format. If we can get it there, we get the answer from this right here. So for this one here then, was a squared. That's the constant. So that'll be 3 squared plus, and then we want something else squared to represent the u. So 4x, we can write that as 2x. And then we have to, again, come up with something for the dx. So to do that, we simply make the selection here, u is equal to 2x du. Due to 2x is 2, so this will be 2 dx. Divided by 2 here. This divides out, so now we can replace the dx by du over 2. So let's write it this way. This will be then, instead of dx, this will be du, but it's du over 2, so let's just put the 1/2 out in front. And this would be then 9 or 3 squared plus the u squared, where u is 2x. And then from this you can go directly to the formula. It was du over a squared plus u squared. So the answer to it was, this one of course has the 1/2, so that carries over 1/2. And then the coefficient was 1 over a. A in our case is 3. So let's put it in front also, 1/3. And then it was arc, for this one it's arc 10. And here in the parentheses we have u over a. In our case, the u is 3x. The a is 3, plus the constant of integration. And then to simplify, we multiply the 1/2 and the 1/3 here. We get 1/6 here. So the final answer for this one then is 1 over 6 times arctangent of 2x over 3 plus the constant of integration. Thanks for watching. We'll see you next time.